1.7 is what we're going to do now. 1.7 is the precise definition of a limit. So remember the intuitive definition of a limit that we looked at in, was it 1.6? I'm not sure if it was 1.6 or 1.5 that they told us about it. But they used words like arbitrarily close and sufficiently close. Those are the kind of things that they said. And so I used the word very, very, very close. And said those kind of things, and so the idea is to put a number on arbitrarily close and sufficiently close, and so that's kind of the idea. And so a mathematician, when you start talking about how close you would like to be, they will say, "Tell me what your epsilon is," and that's typically the measure for how arbitrarily close I want to be. How close does it have to be before I'll say, yeah, that's the limit. So the precise definition uses that epsilon idea. And they say all the same things that we had before about, it doesn't have to be defined at A itself and all those kind of things. And the limit of f of x as x approaches A is L, and we write this. And then here's the part. If for every number epsilon greater than 0, so you set the epsilon, and then I will find you a delta, so that's the symbol for delta, bigger than 0, such that this is true, then this is true. So the person that's saying how arbitrarily close I have to be before I can say that's the limit will set the epsilon, and the other person, the idea is then you have to be able to find a delta that would the distance between x and a would be smaller than delta, so that this would be true. So just looking at what that part means, just looking. 0, this is bigger than 0. Well, we know that would be bigger than 0. It's absolute value, right? And not equal to 0. Well, this is x approaches A, and so we don't want that to be exactly, x and A are not exactly the same size, right? Because it's just getting really, really close. And because it's an absolute value, it's going to be greater than 0. So what just does this part of it mean? And what that part of it means is the distance between x and A is smaller than delta. And so the distance between those two things has to be smaller than delta. So we're going to look at some problems, just 3 in here, and see how we do. So they've given us, they say use the given graph of f to find the number delta such that if this, then this. And so f of x minus 2 is less than 0.5. And they've drawn the picture out for us so that we can kind of see what's going on. Here's our function going along. We have an open. And they must be finding the limit as x goes to 3. X approaches 3 is what they must be finding the limit for. And they haven't set a very small epsilon. Usually epsilon's kind of a smaller number than that, but 0.5 is what they've set it out so that you can kind of see and look at. And so 0.5 would then go, if 2 is my limit, would go from 1.5 taking away and up to 2.5. So anything in here. And so this is 0.5 is my epsilon. I have to find a delta value that goes with it so that the distance between x and 3 is smaller than delta. And I want to fall inside here. If I picked 0.8, I just want to show you, because this distance right here is 0.8. then that would mean that I would have to be able to go 0.8 on this side. It's symmetric. And so if I went 0.8 on this side, I would be here. And if I looked at, well, where am I at as far as the function, I would be outside of the range of only being half away. So I cannot pick the bigger value, the bigger distance here. I need to pick the smaller distance here, which is 0.4. 3 minus 0.6 is 0.4, because if I come over this side, 0.4, and I go up here, dot, 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 I'll fall within the half that I wanted to be. So my delta needs to be smaller than or equal to 0.4. So it's okay for my delta to be equal to 0.4. That would do the trick. But any value smaller than 0.4 would also do the trick. It would always put me within 0.5 of 2. And so that's the idea, is that I want to be so close to 3 that my output is within 0.5 of 2. And so if I get beyond 0.4 away, on the low side, on this side, right, then I'll get outside of that. If but anything smaller would be okay. Okay, so we're going to look at this one, and they say to illustrate this with definition 2. And so that's this story here. I think if we go and look at definition 2, so this is x minus a is less than delta, right? And in our case here, RA is 2. So this is if, and this is then, and then this is f of x minus L is less than epsilon. And then they're letting epsilon be 3 different values. So I'm going to leave it as epsilon until the end, and then I'll be able to tell you the delta that goes with each epsilon. And so that'll be what we'll do there, because that's what they're asking us to find, is the delta value that goes with each epsilon. Now the function is 5x minus 7, and the limit is 3, less than epsilon. So this is the absolute value of 5x minus 10 is less than epsilon. And so I can factor out a 5. So this is 5 times x minus 2, absolute value around it, is less than epsilon. And I can pull out on absolute value, if I have a product, you can take the absolute value of the pieces, and the absolute value of 5 is 5. And the absolute value of 2 minus x, I don't know what x is, so I have to leave it in the absolute value there. And so my x minus 2 has to be less than epsilon over 5. And you notice that this is what I have here. So I'm okay as long as my delta is less than or equal to epsilon over 5. And so the different epsilons they gave us, right? So they said that epsilon was equal to 0.1. Oh, that's not a 1. That's not a 1. I don't know what I had. So that would mean that for that one, the delta would have to be less than or equal to 0.1 over 5. 0.1 on my calculator, I'm doing that, which is 0.02. So for this one, the delta would have to be less than 0.02. It would be okay for it to be exactly equal to 0.02, but anything less than 0.02 would be okay as well. And when your epsilon is equal to 0.05, then your delta has to be less than 0.05. 5 over 5. That means your delta has to be less than 0.01. So it'd be okay to be exactly equal to 0.01. Some people can't stand if I don't put the lead zeros, so I'll put them in there so that I won't drive anyone crazy. And then if your epsilon is 0.01, then your delta would have to be 0.01 divided by 5. Your delta would have to be smaller than and it certainly would be okay to set your delta to be exactly equal to 0.002. And so that's kind of the story on there. And so that was a good thing there. We just kind of figured out what it would have to be, what we would have to set our delta to be there. And so it was so nice, right, that it set right up there. Okay. So this one here is asking us to prove the statement using the epsilon. Oh no, my camera is saying, uh-oh, is what my camera is saying. I don't know why my camera said that. Prove the statement using the epsilon and delta definition of the limit and illustrate with a diagram like in figure 9. So we'll give a try for doing that. And so kind of our story here is that we have 0 and then the absolute value of x, and then this is minus -2, right? X minus a is less than delta. So if this, then this, and it's the function, remember, and our function is 3x plus 5, and our minus our limit, so minus -1, is less than epsilon. And so when we clean up a little bit here, this is x plus 2 is less than delta. And this is, what do we got here? Absolute value of 3x plus 5 plus 1 is less than epsilon, which this is 3x plus 6 is less than epsilon, which that same trick that we had from before, factoring it, and then you can pull out the 3 just like you pulled out the 5 on the last problem. And you can divide both sides by 3. And so as long as, notice, as long as your delta is smaller than or equal to epsilon over 3, then this will prove this. And so that's kind of the story there. And so you pick the epsilon and I'll tell you what the delta has to be. So whatever you pick for your epsilon, I'll divide that by 3 and then I'll pick that value or a smaller value. They wanted me to illustrate this with a lovely drawing, and I might be too tired to do a lovely drawing, but I'll do my best. So y equals 3x plus 5 is just a line. And I'm going to pick just 2 points on the line because I'm feeling like that would make it easier for me to draw. I'm thinking about also picking -2 as a place on the line, and so if I pick -2, that's at -1, right? So over 0 up 5. Wish I had grid paper. I think I do have grid paper. I actually went and got some today. -2, -1 right here. And I have a ruler somewhere. I have a ruler So I can draw this line in here. Okay, and here's -1. And so what's kind of happening is that you're going to pick your epsilon, and your epsilon is going to be up or down from our line here, and then I'm going to pick the delta to be within fairly close here. And so I don't know if I can get my glasses off, and it's not big enough to really draw it in here. So this distance here on either side there, and then up here, it's not very good. Maybe I should have made it bigger. But here is on my delta, right? And I have to pick my delta to be epsilon over 3. Okay, I think you should blow that up so that's a little bit bigger. Not blow it up like, so I wanted this like that, so that this is epsilon away here, and then when you get here, then you want that to be, it's just a wee bit over our epsilon over 3. This side's over here is a little closer. Okay, my friends, that's 1.7.